Welcome back to the Game Blocks tutorials. This tutorial will cover simulation. So at the high level, when writers write a series of one-liners for a character in a game that maybe goes through a sequence and then hits a random set at the end, they're kind of simulating the thoughts inside of a character. They're making a piece of software seem like a person, both with that sequential progression as well as the randomness and the writing. So this is somewhat of a similar mechanism, kind of focused more on behavior. Writers aren't going to build the simulation logic of a game, most likely, but they can do things like suggest interactions, like in Half-Life, where if the player turns off a light, a scientist walks over, turns the light back on, and then mutters something to the player, to the effect of, what the hell are you doing over here? Those kind of interactions, I think, are another great way to convey character and story. And what we're going to do is look at how to simulate that sort of thing in BYOB to create a game, a lot like Sims, or to create interactions like that in a more traditional type of adventure game, where things can be happening dynamically or happening in parallel with the movement of the player. So what we're going to do is step through the key mechanism for that, which is a timer. What you want to do is basically be telling the characters in the world, decide something. It's time to decide this, it's time to decide again. Just let them know they're alive, basically. And so what we do is just create a continuous loop where, I'm going to get my sample here. It's a continual loop where we're just going to wait a couple seconds in between each message and then send ourselves a message letting us know it's time to decide something. So I'll create a new message, which is player decides. We wouldn't be controlling the player typically, but unless it was a simulation game and the player was a simulation, so maybe we would, I guess. Did I miss? I missed. Oh, I did type it right. Okay, I thought I misspelled it. All right, so we're going to call this sprite player, and we already have the key mechanism for a simulation, which is just ticking the system, sending an event in, letting us know we need to decide something. So what we're going to do is basically decide something every time we get that message. So what we will care about, we won't have our own loop for deciding. We'll wait to be told it's time, and then we're going to make it a simple decision. We could be having a more complex decision based on elements in the world, strategies, moods, that kind of thing. But we're just going to kind of pick a random thing to do. We're going to move around or turn around, that kind of thing. So what I first want to do is create a local variable. When you're creating a simulation, each individual actor kind of should have its own state, its own kind of state of mind, I guess you could say. And this is not exactly an interesting part of its mind, but we're going to have just a random variable for this sprite only that will only apply to us. So we can set it and not worry about anybody else looking at it or changing it. So we're basically going to set it to a random value. Then we'll have a more interesting state variable in just a second. So picking a random number from 1 to 5, and then we'll do something with that number. This will determine what our decision is. So if r equals 1, I know I'm going fast, but since it's video, I hope you'll be able to pause and check out what I did. So I grabbed a condition from operators. We're going to check if r is equal to 1. And if it's equal to 1, what we'll do is we'll set a different variable. So we'll actually change our internal state, 1 in 5 times. And for that, we'll need to create our internal state. And we'll just, instead of a mood or something more, dramatic, we'll just have a walking variable. Not for all sprites, but for us. So by putting inside of us, it becomes our internal state, our internal thoughts. And if we're walking, we'll be doing something. I'll show that in just a second. So we're going to set walking to 1. We'll use numbers. We could type in the words true or false if that's easier to read, but we'll be geeks and just use numbers this time. And we'll duplicate this logic and basically say if R is 2, we will turn off our walking. So we'll turn it back to 0. Okay, notice I right-clicked on the if to duplicate that block of code. It's an easy way to do things quickly. And the last thing, what do we have here? Oh, actually what I want to do is we want to turn this off most of the time. We don't want to be walking most of the time. So I'm actually going to put a different action there. We're going to turn a direction. So 20% of the time we'll start walking, 20% of the time we'll turn a random direction. So instead of turning 15 degrees or a number, we'll pick a random number here too. Okay, and then let's do the condition greater than for this stop walking state. So we'll do another if. We need a different operator. Okay, we have greater than. We can right click on just the R to duplicate it, put it in here, and we'll say if it's greater than 2, then we'll set walking to 0. Okay, so there we're making decisions, setting our walking state, turning sometimes. I'm going to throw one more block on here that I know I need from debugging, is that if we're at the edge we're going to bounce. It's going to turn us around. That'll keep us from getting stuck at the edge of the screen. And so the only thing we don't have is actually a walking behavior. So, again, walking is a simple example, but you could imagine this being a mood and the character, crying or like emoting something, saying something when they're in a certain state. What we're going to do is have that separate state, but it's just going to be a simple movement. So we'll grab a forever if, and we'll just check if we're in the walking state. So we'll just do an equals check. I could just drag this from over here, couldn't I? Not random. We want walking. Okay, no, I couldn't have dragged it, so we're doing a new variable. Walking equals 1. If we are walking, we'll just move forward. I'm just going to move 1 step forward. Alright, so this should do it. So we should have an event going into the system. We're catching the event. This event could be coming from somewhere else, and we'll show that in a second, how to set up a system for doing that. But we catch the event every 2 seconds, decide to do something different, and then this over here is just a separate process. Could be emotes or something, but in this case it's movement, and it moves us forward when we're in the walking state. So you see walking turned to 1 briefly, and while it was 1 we were moving. Let's give it a couple seconds. We're not deciding to do much interesting. We see walking is 1, so we're walking. We bounced off the wall. Let's see if we can rotate at least once before I stop this exciting demo here. Okay, well, we're not going to wait forever. There we go, see rotated. So that's the idea. So we have a character with some behaviors. So what I want to do now is show how to bring another character into the system. So this is a somewhat advanced topic, but we'll look at creating a list of all the actors in the game and then creating kind of global ways to interact with them. And one will be sending a global decides message. So what we'll do is first create a global list. Down here we'll make a list called actors, and we want this available for all sprites because every part of the game will interact with this list of actors. Okay, so there it is. You see it over here. So back in the stage is a good place to do some global handling. we will basically manage this list. So the first thing we want to do is initialize the list. And since we could be running the game and it could get in a state with various actors in it and whatnot, we want to start out by deleting everything in the list. So we start fresh, and we'll build the list of actors we want in the game. So we do that with adding things to it. So we're going to add the player. Just by just use the name of the sprite. It's good to use the name of the sprite for these systems to keep things clear. And we'll have an enemy too. Okay. That's what we want to do. We want to reproduce that ticking mechanism, that sending the decides message into the world, but do it in a generic way, so it'll send it to every sprite that cares about it. So what we'll do is create something running in parallel. That's going forever. It's doing what we're doing before, where we had a delay before each message, 2-second delay. And here we're going to go through a series of steps to count across the list. We want to count the items in the list and do something for each one, for each actor. So we're going to create a local, in the stage we can't create a local variable, which is unfortunate. So we're going to create a variable with a unusual name to count. So it's I, but we're going to do it for the stage, so I_stage. We're going to use this to count through the list. So we'll start out by setting it to 0. We're going to repeat. Now repeat is another standard Scratch mechanism that repeats over the length of the list, or repeats the code inside of it X number of times. So this would repeat whatever we put in here 10 times. We want to repeat the number of times that there's an item in the list. So we want the length of actors. So it's already set to actors. We could pull down to select the list we want. So we're going to repeat over the length of the actors. Each time we're going to add 1 to our counter. Oh, not set. We want change. Change by 1. And lists are indexed from 1. So by adding 1 the first time, we're now going to be accessing item 1 of the list. So all we have to do now, we know what item in the list we're dealing with. We just want to broadcast a message to that object. So there we go, broadcast. Now instead of pulling down something from a list, we can actually construct the name of the message, which is a very convenient fact that lets you kind of generate your own messages on the fly. So we use this join from the operators section. And we're going to join the name of the actor to decides. So we're going to pull something out of the list to get the name of the actor. We do that with this item bubble, item blank of actors. And the number for the actors is going to be from this iStage variable. So there we go. So for each time we'll add 1 to this iStage variable, and we'll be getting a different item from the list, and we'll be making this message that's going to be the name of the actor times, with decides, so player decides. So this should run now and should be sending us the event we need. So we no longer need to be sending ourselves the event. We can just get rid of the script. So no actors will need to have their own script like that. And things should still work. Now, because we're on the exact same clock, you might say, why don't we just send decides into the system? Every actor can listen to decides, and that's true as well if everything's going to be on the same timer. But this idea of having a list and a system like this lets you then potentially put things on a different timer, or have some logic as to which actor is getting a decision message sent to it. You might be checking if actor is active. That kind of thing. So I just wanted to show having this actor list as a way to have a mechanism that's somewhat generic that you can use for various things. So there we go. That's the basic structure for a more global system. Let's go ahead and add an enemy so we can see the enemy getting driven by the system as well. So I'll grab a ferocious looking enemy. There we go. Put him here. Call him enemy. And now we'll create the same kind of behavior inside him. And the easy way to do that is just to drag scripts from this sprite to the new sprite, hover over it, and what happens is it gets duplicated inside of him. And not only that, the scripts have been duplicated, but so have the variables. So these local variables, you see they're below this line, that means they're internal to this sprite only. They're actually separate copies of these. So he has his own walking state. And again, this could be his own mood or some other state, but he has his own internal state, and he's checking his own internal state to see if he should be walking or not. So we don't want to wait for player decides, we want to wait until enemy decides to send to us. And then we'll make our decision. So let's see all of that run for him too. So yep, you see this blink once in a while, he's getting a decision message to let him know to do something. And we see him start walking, you'll see him move too. Nobody wants to walk today. Okay, so this is kind of the general mechanism for having multiple objects in the world, taking actions, making decisions. What I want to show now is a quick example of using that actors list to generate another kind of event. And this will be the the second type of event you'd want actors in a simulation to respond to would be an instantaneous event, a game event like a window breaking, the player doing something like answering the phone, something like that. So you also want these actors to have methods for handling those instantaneous actions, because it's instantaneous events. So what we'll do is create a collision script for the player, which just generically sends out an event that the player has bumped into something. And the reason you want to do something like this in a generic way is that you might want to have a system where the player says something or objects say something when a collision happens, and you might not know at the start of building a game what all those reactions might be. You just want to kind of have this event being generated so that if you come up with a funny idea or there's a particular type of object that needs to have a strong reaction, you can then write a script to handle that and already have the event being generated. So we'll go ahead and we'll do looping over the list. Let's see if I can save time by dragging. No, let's not do that. Let's just build it. I'll build it quickly. I don't want to mess up the variables. So let's just build a list here. I guess I've got this empty space up there, so I can add it up there. We'll create a script that does collision like you normally do, where you have a forever loop. And what we're going to do is, instead of forever just having an if in here saying if I'm touching this, do something, we're going to count through the list like we did for the global event. And we're going to create a local counter. So within a sprite you can create a local variable. So we'll just name it I. We don't have to name it something funky. So we'll have a local counter. And we'll do the same mechanism we did in the stage, where we're going to count over the list. We're going to set it to 0, and then we're going to repeat over the number of items in the list. So instead of 10, we'll grab the number of items in the list. Length of actors. So that's set up for us. That's nice. And then we'll change the value of I by 1. Okay, so now we're counting numerically through the list. And here's where we put our condition to check if we're touching something. So basically, we'll have this touching condition from the sensing area, so if touching. And we can actually put a name of an actor in here. We don't have to use the pull down to grab a specific actor. So we'll get the name of the particular actor we're iterating over at the moment. So we'll grab item I of actors. There we go. Okay, so for touching a particular actor, then we want to send an event to the whole game, letting anybody who cares know that this collision has happened. So we'll do a broadcast. And again, we can construct our own message here with 2 different pieces. And as an aside, you can nest these join commands as well to create more complicated strings, but we don't need to do that right now. So we're going to say so-and-so collides. And we could say this whole thing could be player enemy collides. We could put both strings together by nesting these joins. And then drop another join in here. But we're just going to say all we care about is a collision has happened with a particular actor. We'll assume it's the player. So we need to get the name of who has been collided with. We can get that from the actor list. You know what? It's the same thing. For touching item I have actors, we're going to join the name of the actor to collides. Okay, and that's it. So this is a generic collision script, iterating over the list every split second, and then sending out a message that we've collided. And in a slow game like this, just so you don't flood your game with messages, might be worth just putting a little weight here, like maybe 0.3 seconds or something, just to be conscious of performance. So there we go. This should be sending a message, and we just want to have a reaction to that, right? So maybe we'll have the enemy react to enemy collides. So when I receive, not enemy decides, but enemy collides, notice we have to enter these into the system manually. It's not going to automatically put every possible message we might generate. We have to say we're interested in that particular message. We're just going to say something when that happens. Okay, just for a split second, and let's see this work. Go ahead and look at the script here. So we're running. Let's see if they're going to collide. It might help them collide. There we go. Well, it's ignoring what I wanted them to do. See if he bumps him. Stick this guy down there. There we go. There we go. You see him reacting to that message of colliding. Okay, so naturally this could be more robust and only setting this certain amount of times or only reacting to it every certain number of seconds, but you get the idea. So the characters are moving around, making their own decisions, and at the same time reacting to instantaneous events. And with a little bit of imagination, you can picture something like The Sims, where the characters are doing more meaningful actions and reacting to things the player might be doing in the world. And this way, you can create what I kind of think of as story threads. Actors doing things within the game, simulation, that are meaningful, express their character, express the state of the game, outside the normal kind of cutscene story info dump mechanism. So that concludes the simulation tutorial. Note that we did this all with standard blocks that you can find even in Scratch. So there's nothing fancy in the block library you need for this. It's just standard tools. So enjoy.